Yeah, it's on.
Alright, so long title. Exponent properties, dealing with multiplication. That's what we're talking about today. Alright, so product of power. Ready? Product of powers. Well, basically, if you have a base with an exponent and the same base with an exponent, what do you do with those exponents? Yes.
Multiply them times, or you add them together.
Yeah, the base stays the same. That doesn't change. All right, and that becomes n plus n. Okay. You add the exponents when you multiply like bases only. What do you do with the coefficients? Yeah, you should get rid of one. No. Here's an example. Example 1. X squared times x cubed. Let's do this first.
X to the fifth.
X to the fifth. Alright, so if I expanded this, this is just for your benefit here. X squared is just x times x, isn't it? And you have a multiplication. Then you have x times x times x. Well, is that x to the fifth?
Yes.
Okay, so that's why that works. Alright, so the shortcut is add your exponents. Example 2. 2x, now we have a coefficient, times x cubed. First of all, what's the coefficient in front of x cubed? In front of x cubed.
Oh.
Min 20. Alright, so really, this is all just multiplication between everything, and community property says I can rearrange everything. You don't have to do this. I'm just showing you that it all is the same thing. Alright, this is 1 for an exponent, so what is my answer?
2x.
Raise your hand. 2x to the 4th. Good. Example 3. Let's do a negative 2x to the 4th times 3x to the negative 5. Yeah, get a little extra here on this one. Yep.
Negative 6.
What's 4 plus negative 5? 4 plus negative 1. Or 4 plus negative 5.
Oh wait, negative.
Negative 1. Okay. All right, now, we're going to get into negative exponents later on in the week, and we'll talk about that in a minute. Or later, but I'm going to go on from here, okay? All right, now, we have, that was the product of powers. Now we have the power of a power. Okay? This is product. This doesn't mean we're multiplying exponents. That's not what that means. We have multiplication. What do you do with the powers? All right. So here we have exponents raised to other exponents. Okay. So here's the rule: the base raised to an exponent raised to another exponent.
Whoa.
I think I know what you do.
What do you do?
Do you multiply and then?
Oh, yeah.
Multiply. Okay. So here's a basic example. Example 4. X cubed to the second power. Now I'm going to expand this just to show you that it works. First of all, what's the answer? Ready?
X to the 6th power.
X to the 6th. Now watch what we do here. The 2 here means I need to multiply this by itself twice, right? Okay, so I have x cubed times x cubed. Everybody agree? And that's the same thing as x times x times x times x times x times x, which is x to the 6th. Okay, so it does work. Again, you don't have to write any of that stuff. You can remember the shortcut. All right, example 5. Let's see, x squared to the negative 3 power is min.
X to the negative 6.
Yes, x to the negative 6. Now I want to make sure we understand each other. Negative exponents or positive exponents have no bearing on whether or not the value of the whole expression is positive or negative. This does not mean that this value is negative. You understand? The negative on an exponent means something different. Again, we'll learn that later this week. Maybe tomorrow. Not sure. All right? So all you do now is just understand that that's how you can get your exponent. Example 6 is 3x cubed over y squared to the 2nd power. Now, you need to, this is one that you'll need to understand what to do here. This is why you're wrestling this problem. So, now we have a fraction inside the parentheses, and all these exponents raised to exponents. So, here's the obvious question. Is the 2 applied to all of the exponents, or just the exponents, or is it all applied to everything? Top, bottom, everywhere?
Everything?
Everything that's inside here, right? Well, doesn't everything have an exponent?
Yeah.
What's the exponent on the 3? So, we apply the rule to every exponent inside the parentheses. Notice there's not a plus or minus sign. We'll get into that after Christmas. But at this point, your answer should look like this. 3 squared, x to the 6th, y to the 4th. And then if you can tell me what 3 squared is, you need to do so. So the real answer then is 9x to the 6th, y to the 4th. So if you had 20 squared or whatever it was, it should have been 400. Got it?
Well, like, okay, can you do number 16 real quick? Because I'm not sure what you do.
This is number 16 in your book. Go ahead and read it to me.
17 times 16, parentheses around that.
Both of them?
Yeah. To the 4th. Would you distribute that?
Yeah, because, well, yes.
Okay.
Remember, that 4 goes into each of those.
Okay.
Oh.
Okay?
Because I multiplied the parentheses and then,
But you can.
oh,
You can do what's inside first. Here, there's nothing you can do in here. Here, you could go ahead and multiply 17 times 16, and then take it to the 4th. Or take each of them to the 4th and then multiply. You get the exact same answer. Okay.
but we're supposed to keep the exponent. Oh.
Whatever the instructions say. All right, here's another example. Example 7 is, in parentheses, 2x squared raised to the 3rd power, all over 3y. Everybody try to figure that one out. Brody, 6 isn't right?
Wait, I'm
Hey.
What's 2 cubed?
2 to the 4. No, 2 to the.
Yeah.
Eight.
Wait, are we
Eight.
supposed to solve it? Because they told us to write it in,
Hold on, I'll get to the instructions here in a minute. Wait till we're done.
Okay.
Yeah.
8x. No.
Power to a power, you-
8.
Power to a power, you multiply exponents. Exponent raised to an exponent multiplying. What's 3 times 2?
I mean,
3 times 2 is 8. Not 2 cubed. 2 times 3.
oh, 6. Over 3y.
Over 3y. 3y was not affected.
Oh.
Okay? It was not in the parentheses, so don't make that mistake. Okay?
Oh.
Oh.
So now let's go back to number, example 8 here. 2x squared times 3x cubed raised to the second power. What do you do first? Nate?
First you would take 3x cubed and distribute the exponent of 2 to
And what do you get when you do that?
you would get 2x to the second times 9x to the sixth.
That's right. Now what do you get? X to the what?
12.
Am I raising that exponent to that exponent? Or am I just multiplying the bases together? The first examples we were doing, when you multiply like bases, you add the exponents. When you raise an exponent to an exponent, you multiply them. Yeah, we add. So this is 8. So you guys on this lesson have to know when you're multiplying your exponents versus when you're adding them. Okay? So when you raise an exponent to an exponent, you have to multiply it. If you're just multiplying like bases, then you add them. Okay? Any questions? I see I had 8 examples there. I hope that helps.
okay.
Let me do something. I'm gonna make up another one based on what I saw in the assignment. Example 9. Let's see. I don't have another one. So let's see. How about negative 4x cubed raised to the second power times negative x raised to the third power. Yeah,
I just worked it out.
yeah, give everybody a second. This is specifically done to address a certain situation. So, all right, Luke.
Is it, 16x to the sixth times negative x to the third?
Why is it negative x to the third?
Yes. Because, x, the exponent is 1, and 3 times 1 is 3.
Why is it negative though?
Because it's negative in parentheses.
Why is it 16x?
Oh, wow.
That's my next question, but I wanted to explain the negative on the x.
It's negative because the negative sign is unaffected by the coefficient.
No, the negative is on the coefficient.
I mean, unaffected by the exponent.
Sure it is. It's affected by the exponent.
I just left it how it was.
I don't think it gets touched by anything.
It's not, wait, hold on, everybody have a chance now, watch. And then I'll give you the short read. This means you've taken this times itself 3 times. So a negative 1x times a negative 1x times a negative 1x. Negative 1 times negative 1 is positive 1 times negative 1 gives me a negative 1x.
But we haven't even solved it yet.
Cubed. Hold on, I'm not done. So I'm trying to tell you why this is negative. The point is, this still has a a 1 for an exponent. A negative 1 raised to the third power, an odd power, a negative value raised to an odd power
It'd be negative.
gives you negative. A negative value raised to an even power
Gives you a positive.
gives you a positive. Negative 4 times negative 4. Positive 16.
Oh,
But we
I
still
I
haven't
did
even solved
negative 4
that yet.
times 2.
Okay, no. Don't do that. What?
That's after you solve it, isn't it? That it's negative.
This part is that. Now we solve it. Keep going, one step at a time.
But it would, like what I'm saying is if you hadn't solved that, it would still be negative 4 to the second. It wouldn't be positive 4 to the
Right.
second. So it's negative anyway because you haven't solved it yet. Correct?
Now, dude, that is the way it is because of what we solved here. We solved this into this.
Okay, would it be negative 1 to the third times x to the third?
Well, what is negative 1 to the third? I've gone ahead and done what you did to this 4. You went ahead and solved the negative 4 squared.
Okay,
So I went ahead and solved the negative 1 cubed.
so it'd be negative 3x cubed.
No, negative 1 to the third is not negative 3. You just told me negative 1 times negative 1 times negative 1 is negative 1, not negative 3.
Oh yeah, you're right. So it's.
I know I'm right.
So everything's solved.
16 times negative 1 is negative 16. Excuse me. And x to the 6 times x cubed.
Oh.
X to the 9.
Assignment. Two 48 evens and mixed review evens.